Hello everyone, welcome to my channel CodeU. In this video lecture, we will learn about binary search algorithm. I am going to explain binary search algorithm in detail, so it will be very helpful to you if you watch the video till the end. The agenda of the tutorial is to understand what is binary search algorithm and how it works, and see step-by-step guide to learn binary search algorithm with an example. In the next videos of the series, we will learn about analysis of time and space complexity, and also we'll learn about how to write code for the binary search algorithm. What is binary search algorithm? It is an efficient search algorithm to find target value in sorted sequence of elements. Or you can also say it can be used to find the position of target value within a sorted array. If you carefully observe, there is something common in the above statements. As you have guessed, it is the highlighted part, right? That is, binary search algorithm works only on the sorted input. The point to be noted here is that sorted input is the prerequisite for binary search algorithm to work. How binary search algorithm works? It will search in the sorted array by repeatedly dividing the search interval into half until target is found or no search intervals are left. In fact, this is the reason why binary search algorithm is efficient. You can also make a note of this point that binary search algorithm repeatedly divide the search interval into half. Now let's take an example and try to understand how binary search algorithm works. First, we'll look at the code. It is a binary search function which is returning an integer value and taking 4 parameters. We'll try to understand what are all these parameters are. First parameter is array of integers, and this array of integers is going to be in the sorted order. This is the pre-assumption that array of integers is sorted. And the next parameter is L. L is the starting index of the current search interval. And next parameter is R is the ending index of the current search interval. And next parameter is K is the value that we want to find whether it is present in the array or not in between the search intervals L and R. And this function is returning integer value. If K is present in the array, it will return its index, and if K is not present in the array, it will return -1. The first thing to do is check whether current search interval is valid or not. To do so, compare ending index of the current search interval with the starting index of the current search interval, that is, compare R with the L, and if R is less than L, that means current search interval is invalid and it is empty. So in that cases, K is not present in the array, we can return -1. And remember, this condition meets only if K is not present in the array. In such cases, search interval is empty. If the current search interval is valid, then we can go ahead and find the mid of it. To find the mid, simply put the values of L and R in the formula L plus R minus L divided by 2. This will give you the mid. You can also directly use the formula like L plus R divided by 2, but it is best practice to use this formula since this can avoid integer overflow. Once you have a mid, we'll try to check whether K is present at the array of mid or not. If K is present, then the mid is going to be our index. So we can compare is K equal to array of mid. If K is equal to array of mid, then mid is the index where K is present. In such cases, we can return mid. If K is not equal to array of mid, then we'll either go to the left half of the current search interval or to the right half of the current search interval. To go to the left half, simply compare K with the array of mid. If K is less than array of mid, that means K is going to be the less than all the elements which are present after mid. So in such cases, we can blindly ignore the right half of the part and we can go to the left half of the part. That is, in such cases, if K is less than array of mid, we'll go to the left half of the correct search interval. And if K is not less than array of mid, that means K is greater than array of mid. In such cases, K is definitely going to be the greater element than all the elements which are present before mid. So in such cases, we can ignore the left half of the part and we can directly go to the right half of the part from here. Take an example. First, let me explain you what you see at the left side of screen. It is an array. First row is the indexes of the array, second row is the values of the array. To make it easy for the understanding purpose, I am using one more row to represent indexes of the array. The array is, in this case is 1, 2, 3 up to 9, and the length of the array is 9. And suppose we want to find k is equal to 3 in this array using binary search algorithm. Initially, the length of the search interval would be the whole array. So in such cases, that is in the first case, L is at the starting part of the array, that is 0, and R is going to the end of the array, end index of the array, that is 8. In this case, L is 0 and R is 8. First thing to do is compare, check whether current search interval valid. Yes, in this case R is greater than L, so it is valid. Now we'll find mid. To find the mid, you can use this formula, and in this case mid is 4, and the value at 4 is 5, that is array of mid is 5 in this case. Now we'll compare whether k is present at array of mid, that is whether 3 is equal to 5. No, in this case 3 is not equal to 5. So we'll either go to the left half or to the right half. To go to the left half, compare k is with array of mid. In this case k is 3, array of mid is 5. Compare 3 with 5. Is 3 less than 5? Yes, in this case 3 is less than 5. So we can go to the left half of the current search interval. That is, since k is less than 5, it is going to be less than all the elements which are present after 5. That is, because the array is in sorted order, if the k is less than array of mid, then it will be definitely going to be less than all the elements which are present after array of mid. So in this case, we can go to the left half. Now let's take one more example. Let's take k is equal to 9. If in this case also mid is 4, check whether 9 is equal to array of mid. In this case k is 5, array of mid is k is 9 and array of mid is 5. Is 9 equal to 5? No. Now to go to either left side or the right side, compare 9 with the, that is k with the array of mid. So is 9 less than array of mid? That is 9 less than 5? No. So in this case, we can go to the right side. Since 9 is not less than array of mid, that is k is not less than array of mid, it is definitely not going to be less than all the elements which are present before array of mid. So we can blindly ignore them, and we can move on to the right half of the current search interval. You might be wondering, why do I have a stack here? If you look at the code once again, to implement binary search algorithm, we are using recursion. And recursion internally uses stack to maintain state of the previous function calls. So here I will try to simulate how recursion internally uses stacks. Now let's take this as an example and try to find k is equal to 3 in the given array here. Initially, we'll start with the whole array, that is length of the current search interval for the initial call is the whole array. That is, we'll start from L is equal to 0 and R is equal to 8. And the first thing to do is check whether current search interval is valid or not. In this case, R is 8, L is 0, so it is valid since R is greater than L. That is, this condition doesn't meet, so it is a valid interval. Since it is valid, we'll find the mid of the current search interval. In this case, mid is 4. Once we have a mid, compare whether k is present at mid or not. So compare k with the array of mid. In this case, k is 3 and array of mid is 5. Is 3 equal to 5? No, they are not equal. That means k is not present at this mid. So we can either go to the left half or to the right half. Next, we will compare k with the array of mid. In this case, k is 3, array of mid is 5. Is 3 less than 5? Yes, it is less than 5. So we can ignore this part. You can ignore the part which is after the mid, and we can consider only the left part of this search interval for the next recursive call. Since we are making next recursive call, the state of this function should be maintained. So before making the next recursive call, its state has been pushed onto the stack. You can see when you made the next recursive call, the state of the previous function is pushed onto the stack.
In the previous call, we had L is equal to 0 and R is equal to 8 as our search interval indexes, and this function has made its execution up to line number 18. Now let's see what happens in this in this recursive call. For this recursive call, we have L is equal to 0 as the starting index of the search interval and R is equal to 3 as the ending index of the search interval. That is, this is our search interval in this recursive call, and K is remains same. And again, the first thing is check whether it is valid or not. In this case, this search interval is also valid. Since it is valid, find mid of it. In this case, mid is 1. Now once we have mid, check whether K is equal to area of mid. In this case, K is 3 and area of mid is 2. Is 3 equal to 2? No, they are not same. So we again divide this search interval into half. First we will compare and check whether K is less than area of mid. Is 3 less than 2? No, it is not less than 2. That means we can go to the right half of the current search interval. In this case, right half is from mid plus 1 to R. Again, we are making some recursive call here. Before making recursive call here, the state of the current function, to maintain the state of the current function, we push its state onto the stack again. So remember, this function has completed its execution up to line number 18. So when we have made the recursion call, you can see on the stack there, the state of the previous function call has been pushed here. And in the previous call, we had L is equal to 0 and R is equal to 3 as our search interval indexes, and that function has completed execution up to line number 18. Now let's see what happens in this recursion call. For this recursive call, we have L is equal to 2 and R is equal to 3 as our search interval indexes, and as usual K remains same. First thing is to check whether search interval is valid or not. In this case, R is 3, L is 2, that is 3 is greater than 2, so search interval is valid. Since it is valid, find the mid of it, and the mid of this interval is 2. Now mid is 2 and L is also 2. Now compare and check whether K is present at area of mid. In this case, K is 3 and area of mid is also 3. That means both are same. We have found the index where K is present in the array using binary search algorithm. Now we can return this mid as the index where K is present. Now let's see how this value is returned back to the function from where initial call to the binary search function has been made. When we return value from here, the function which is at the top of the stack will continue its execution from where it has left. Let's see. Now you can see the function which is at the top of the stack has been popped, and it is continuing its execution from line number 18, and again it is returning value. When you return from here, the function which is at the top of the stack again will continue its execution from where it has left. Now you can see the top of the stack has been popped out, and this function has started its execution from line number 15, and this function also returning the value, and when this returns it, the return value will go to the main function call. That's it. This is how the recursion algorithm works, and this is how the binary search algorithm works. I hope I would be able to provide some knowledge on binary search algorithm. Next we will see the summary and important takeaways from this lecture. They are: binary search is an efficient search algorithm to find target value in sorted sequence of elements, and sorted input is the prerequisite for the binary search algorithm to work. Binary search algorithm repeatedly divides the search interval into half until target is found or no more intervals are left.
Thank you for watching the video. Like and share the video if you find this tutorial helpful. Do comment on it if you want to share something on the video. Subscribe to my channel to never miss an update from us, and do not forget to click on the bell icon.